Okay, so if we pick up where we left off in our previous video, we need to now find solutions or answers to our integrals for v1 and v2. So for v1, we're trying to find the integral of the opposite of the tangent of t times the sine of t. And we'll find this integral first. And whenever you're working with tangent functions or cotangent functions, it's highly advised to rewrite them in terms of sines and cosines to make the integration much more straightforward. So this is the same thing as the integral of the negative sine of t over the cosine of t, which is your tangent, times the sine of t with respect to t, which of course is the negative integral of the sine squared of t divided by the cosine of t dt. And oftentimes when you're dealing with trig ratios, it's a good idea to think about your trig identities and also good to think about use substitutions. So you'll notice right now that if you were to do a direct substitution, nothing would work out nicely because you'd have mixed up sines and cosines. But what you can do is rewrite the sine squared as 1 minus cosine squared and turn everything into cosine functions. So in doing so, you're going to have the negative integral of 1 minus the cosine squared of t divided by the cosine of t with respect to t. That simplifies down to the negative integral of 1 over cosine, because again we're going to split. So 1 over cosine turns into the secant of t. And then when you have a cosine squared over a single cosine, that simplifies down to just plain cosine of t. And again, with respect to t. So when you integrate the secant function, you could either memorize it or do another substitution. But that is the natural log of the sum of the secant of t plus the tangent of t, and then the integral of cosine is sine, so you're going to have a negative making a plus sine of t. We do not include arbitrary constants. We'll leave this one right where it is. So again, that's our v1 of t. Well, now go ahead and find v2 of t, and that one is the integral of tangent times cosine of t. And again, just like before, we're going to go in and rewrite this as the sine over cosine. All right, so again, this is the sine of t over cosine of t times the cosine of t that's already there. And you bet, those cosines do cancel out. And you're left just integrating the sine of t, which we know is the negative cosine of t. Once again, we do not use an arbitrary constant here. So now our yp of t is our y1 v1 plus y2 v2. So that's the y1, which we defined as the cosine of t, times the v1 we found, which is negative natural log of the secant of t plus the tangent of t, and then plus y2, which is the sine of t, times the negative cosine of t. And when we distribute, we're going to have negative cosine of t times the natural log of the sum secant of t plus tangent t in absolute values. And then we distribute, we're going to have plus a product cosine t sine t, and then behind it a minus sine of t cosine of t. And those two terms are opposites, and so they will coincidentally cancel out in this problem. It doesn't always happen, but in this case it does. So now our solution, our general solution, is y of t is c1 cosine of t plus c2 sine of t minus our cosine of t times the natural log of the sum secant of t plus tangent of t. And that is our general solution for this inhomogeneous differential equation. And we haven't said this in a while, but again, you can always check your solutions by taking derivatives and substituting them back into the original differential equation, which was on the previous video, but that was y double prime plus y equals tangent of t.